Alright, y'all, we've already done these notes before, but that was like the Thursday before we got out of school, so I thought we could maybe revisit this stuff and kind of start here as we attack our virtual learning going forward this week. I'm not 100% sure of the plan the rest of the week, or excuse me, the rest of the school year, but this week all we're going to focus on is this one section, and again, you've already heard a lot of this, it's just kind of getting back to you. Okay, where we're talking about when you left, we're talking about quadratic functions. And quadratic functions are any function in the form of y equals ax squared plus bx plus c. So you must have that squared there, which means a can't be 0, because if a was 0, 0 times this would make it go away. And that's what that's just trying to say, is a can't be 0. Okay, you could probably find these and kind of look at yours as you're watching this video. Okay, so just to kind of remind you of what's what. The graph of a quadratic function has a U shape, and it could be an upside down U shape, and that is called, hopefully you remember, a parabola. Parabola. Okay, parabola, 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 any of those words, good enough. Okay, all right. So we've got our vertex here. Our vertex is, and I'm going to kind of color coordinate these things. Okay, our vertex is the bottom slash top, not both, can't be both, but like the bottom here and like the top here of the parabola, and it is a point x, y. So the first thing you do is you identify where is the absolute bottom of it. Okay, this is also called a minimum. We'll get to that in just a minute. Matter of fact, we'll probably do that at the same time here. Let's just do that. This is a minimum right here. This is also a vertex. So let's just start with the fact that it's a vertex, okay? That right there and this point right there are vertex. And in these pictures, it is 0, 0. It is not always 0, 0. It actually will be today for the ones that you have to graph, but you'll see other ones where it is not, okay? All right, that's the vertex. Our axis of symmetry is the line x equals and then some number. Okay, so that number though is always the x value of the vertex. It always, always, always is. So I'm going to write that too. Let's see here. Always x value of vertex. Of course it is, because if it goes through here, then it is the x value of the vertex that it goes through, and here as well. And what this does is it divides the parabola into two symmetrical parts. And if you don't remember, symmetrical is like a mirror reflection. So if I put a line like this through that picture, this side will reflect to that side. If I do the same on this picture down here, okay, then this side reflects the same as that side. That again is the axis of symmetry, and this in this case is, let's put AOS of x equals 0. I said it is in the equation of x equals a number. It's always that value because it is 0 right here. Then that gives me an x-axis, an axis of symmetry of x equals 0. Okay. Now, increasing and decreasing intervals. Okay, so increasing is when it's going up, of course. So going up as the value of x increases, so as it goes left to right. Okay, so decreasing, I'm going to get this here, decreasing is of course then when it is going down. Okay, so to determine whether something is increasing or decreasing, if you remember, I talked about taking your left hand trick. This is your left hand because guess what? That makes an L. Okay, and you just cover the left side of the graph, right? The left hand trick. And I look at that and I see an arrow that is going up. Okay, it's going up. So that side is increasing, okay, which means automatically the other side is decreasing. Now what's confusing about that is that it looks like it's going uphill. But again, we always read our graphs left to right. And as I read this graph going left to right, it's going down, 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 down. And then it's going up, 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 up. And that's why it's increasing over here, which again means that that side is decreasing. Okay, I look at my other picture here, okay, and I see, again, left hand trick, left hand makes an L. I cover up the left side of the graph, and I can see that this graph is going down. It's starting here and going down. And it always starts kind of at the vertex here, right? So if this is going down, then that side is decreasing, Okay? And then the other side is increasing. And we're going to talk about how to write that when we get on the next page. Okay? The minimum and maximum values here, I've got a minimum that is the bottommost point of the parabola. And as you can see, this doesn't have a bottommost. Really, it has arrows that keep going down. And so this has a topmost. This does not have a minimum. But this one right here does. It has the bottommost point of the graph. That is a minimum. Okay, and it is always the vertex. A vertex, it says. Okay, and then on the next one, a maximum is again a vertex that is the uppermost. Okay, so as you can see, that is that one right there. Okay, a vertex that is the uppermost point of it. Okay, now we talk about domain and range. Okay, domain and range. Well, the domain is always all real numbers. Okay, so you can just say even just that if you want to. Okay, and the range of these, well, if it's going up like this, then it's going to be y is greater than or equal to 0. If it is going down like that, then it's going to be y is less than or equal to 0. If that number 0 is going to change based on the vertex, really, that's what this is supposed to be. And maybe I'll point to both of those, is the vertex y value. But for everything we're doing today, our vertex y value is going to be 0 because everything's kind of starting at 0, 0 in those pictures. But we'll see some pictures where it's not, okay, when we do some other examples. So with that being said, there's all the vocab notes. Let's get to what I'm actually going to be asking you to do here. On the next page, okay, it's just to identify, if you remember this kind of a homework here, I've got some exact examples from what I'm going to have you do on the homework here and on the next page as well. We'll get to that. But for now, let's look at example 1, and maybe I'll have you guys try 1 or 2 here. On example 1, I find the vertex, which is right there. Okay, it's the bottommost point, so that is a min. That I'm going to write right away. Okay, and that value right there, if you see this graph is going -2, -4, it's going over by, let's see, this is 8, so this is 2, 4, 6, 8, so it's going by 2's as well. So this is the point over 2 and down -4, okay? Over 2 and down -4. So that right there, ladies and gentlemen, the bottommost point is my vertex, okay? 2, -4, okay? From there, my axis of symmetry goes right through that point, right? Because that is what reflects it between the left side and the right side. So my axis of symmetry is always x equals, and it is always the x value, which in this case is 2. I can also obviously get it from right there. Okay, where is it increasing and decreasing? Well, that I also need 2. And again, if I just hold my thing here, my left hand trick again, I can see that that side is increasing, so the other side must be decreasing. Okay, now what we said next, okay, so I have x and 2 and x and 2, is that I need to use these symbols when I'm doing this. Okay, and again, if I just draw a timeline, a number line, excuse me, below the problem, increasing then gets that arrow, decreasing then gets that arrow. So increasing gets that arrow, decreasing gets that arrow. I'll show you how that works when we get to one that's the other way down here. Okay, domain, we already said, is all real numbers, and in this case it's y. The y value of the vertex is what gives you this point, which in this case is -4, and because it's going up, it's greater than or equal to. That's how it works. Matter of fact, did I put greater than or equal to there? Yes, I did. Okay, good. Okay, and that's it. That's how you do these kind of problems. So I'm going to kind of fly through this one here, and then I'll have you pause and try this one here. Okay, so just looking at the picture, which you can see in the notes here, okay, I can see that this vertex right here is at 4, -2. So I'm going to write that down first. 4, -2. Okay, axis of symmetry is always my x value, so it's going to be x equals 4. We can see that if I just draw it in. Okay, and from there we can see, of course, it's the top, so it is a maximum. Okay, is it increasing or decreasing? Well, again, go like this. That is going downhill, so it's decreasing on this side, increasing on this side. And again, if I just draw a little number line, increasing gets this arrow, decreasing gets that, because it's on that side, it gets that arrow. So x is increasing, so less than, again, the x value, which is 4. This is x, decreasing gets that arrow. Again, the x value, that's 4. Right? You can see it showing up a lot. Domain and range, real easy for domain. For range, it's y. It's the y value of the vertex, -2. And because it's going down, it is less than or equal to. When it was going up, it was greater than or equal to. Now that it's going down, it is less than or equal to. Okay? Pause the video. Try this one on your own, just filling in what these things are. Then unpause it and come back and check. Again, the domain is all real numbers. My vertex is -6, 2. Axis symmetry has x equals -6. For increasing and decreasing, I know I need that as well. It is the bottom of a graph, so it is a minimum. Okay, let's see. The range is greater than or equal to the y value, which is 2. Oops, I don't need to do that like that. And then for increasing and decreasing, again, I'm going to, I should have done this already, put my left hand on the left side here. I see that side is going up, so that side is increasing, which means that side is automatically decreasing, because that is how it works, ladies and gentlemen. Draw myself a little number line. Increasing gets that arrow. Decreasing gets that arrow. And that's how we do those types of problems. Okay, we're going to do much the same on the other side, except what we're going to need to do here is actually come up with some points and how to do it. Okay, so there's that. Let's go to the next page here. I'm giving you values to plug in, and so you can see, don't let, again, this confuse you, okay, is we plug in -2, so I've got, I don't know why that's doing that, -2 squared. Oh, it's because I copied and pasted these, my bad. Let's just scratch out all that. Okay, so to plug in -2 here, I would go -2 squared, and I would actually get -4. Then I would go -1 squared. And if you plug that in, it'll square it first and then attach a negative. That's why I'm getting negative values here. Of course, 0 squared is 0. -1 squared is -1. And I'm going to get -4 here. And remember, these look like one of these things. Okay. Before I graph that, I'm going to show you the same thing on this one. I'm just plugging in those values here. So I have 2 times -2 squared, 2 times -1 squared, 2 times 0 squared, 2 times 1 squared, and 2 times 2 squared. And I go plug those values in, and I get 8, I get 2, 0, because anything times 0, 2 and 8. Okay? Don't let this confuse you. It's just plugging stuff in. So I'm going to go plot those points now. -2, -4. It's down here. -2, -1. 0, 0, 1, 1. 2, -4, and guess what? It reflects itself like I want it to. Remember how we said that we have this axis of symmetry that goes through here? And so what that does is if I have a point here 1 away, I got to have another point here 1 away. If I have one from at -4 that's 2 away, I got to go -2 away the other direction too, and they mirror each other. Okay? I'll do this stuff after we get them graphed. So let's graph this other one here. Okay, so I've got -2, 8 way up here. -1, 2, 0, 0, 1, 2, and 2, 8. And again, I know those reflect each other as well. Sorry, my connecting the dot skills are not as great as I'd like them to be. This coronavirus thing is affecting all of us. I want to see, go fill in some things here. I know the domain is all real numbers, so I'm just going to fill that in on both. I know my range is y is less than or equal to when it's down, and y is greater than or equal to when it's up. I'll get to that. The vertex here is just 0, 0. It actually is for both of them, right? And so x equals 0 is easy. Y is 0. That's also easy, right? This is a top point, so it is a maximum, versus this being a bottom point, so that's a minimum, of course. Okay, x for increasing and decreasing is always the x value. So I'm going to put that in there, and then I'm just going to do left-hand trick. That's going down, so decreasing, increasing. That one is going up, so increasing and then decreasing. And draw myself a little number line and follow the arrows, right? On this one, increasing gets this one. So increasing gets that one, decreasing gets that one. Good enough. For this one, decreasing gets that arrow, increasing gets that arrow, and I'm done. Okay? I kind of flew through it, but that's because I didn't want to have a 30-minute video. Trying to keep it to 15, and your homework today looks just like this. Okay? If you look at it here, I've got problems here that look just like it. This is going to be a little more than 15. Those two problems, just like the problems we did on the second page of the notes, right? We've got 2 examples here to look at. You can even pause it here in the video because I've got the answers here, and then go try the problems from the homework, right? Then the next 2 problems are just like these 2 problems that we just got done doing here, where you got to plug it in to get the points, plot those points to form the parabolas, and then get the information from that. Again, that's what you have to do here. Plot it. Don't let this confuse you. When I go to plug it in for 1/2, I just go 1 divided by 2 times -2 squared and plug that in, and I would get 2 right here. Anything times 0 is 0, and you can go from there. Okay? Don't let this confuse you. Again, this means -2 times -2 squared. Plug that in, and I would get -8, and then you can graph that, and again, answer these questions down here accordingly. Okay? On the back side of the homework, or the second page of your homework that's posted on Google Classroom, is a review. Okay? And hopefully these aren't that bad, right? When you see a parentheses, I should be distributing to get something like this. When I see numbers that I can combine, I should combine them like this. And then I need to get the numbers on one side and x on the other side. And I don't want to just tell you how to do that. Hopefully you can do that. Right here again, combine these 2 and get -4d minus 6 equals 6. And I think everybody in my class can do this right now. Okay? For this problem, you're going to have to do a little of both. And I don't want to give you any hints on that. Down below it says use FOIL or the box method. If you remember, that's one of the last things we did before you left, to expand the binomial products. So if you like FOIL, I'm going to start with FOIL actually. A lot of you liked it first. I get x squared. Outside I get plus 3x. Inside I get minus 3x. And last means those last 2 to get -9. And I would suggest, just like I did, to do one step, write it, one step, write it. And hopefully you get a little smiley face guy. Okay? Alright, then I combine my like terms here, and those 2 actually cancel because 3 minus 3 is 0, so I just get x squared minus 9 as my solution. Okay. If I want to do the box method, it's kind of the same thing. I put x, the first term on top, the second term here. It doesn't matter if I switch those around, but make sure minuses are negatives. X times x is x squared, -3 times x is -3x, 3 times x is 3x, 3 times -3 gives me -9. That was how we did that one. Whichever way you like, you do not have to do both. Okay. And then I combine on the diagonal, and those like terms cancel each other out, and I end up with x squared minus 9 either way. Okay? Do that for those 2 problems as well. You're not going to get them to cancel out. You're going to actually get some terms to combine. So you're going to get an answer here. This is not the answer, but x squared plus 13x plus 18. And that is not the answer, but it's going to look more like that with the term in the middle versus the answer we actually did get on this one. Okay? Alright, so you're going to finish those 5 problems here on this page for review. That's part of the work. And on the back side, that will be worth 10 points for this page. Pretty easy 10 points. And then the other 10 points is just finishing up this side as well. Again, you don't need to print this off. You can just give yourself one of these and plot those points. -4, 8 would be up here. -1, 2, 0, 0. And they will reflect. And then you can still answer the questions down here according to that graph. If you don't have graph paper, it's totally okay. Sorry about the sunshine. I kind of like it, but I got a lot of trees here that kind of sway back and forth. So if this was a little bit funky in terms of that presentation, I apologize for that. We're going to beat 20 minutes. We're probably going to beat 19 minutes here. So just trying through this stuff. And that is all we're going to do this week. I'm not even going to give you a quiz. It's just going to be your points for this week, which will count towards your quiz grade, are just to finish up this assignment and this assignment here. I will post more about that on Google Classroom. Have a good week.